Welcome back to this wonderful world of mathematical discovery. 2.5, writing equations in slope-intercept form. So far, what we've been doing is taking equations and graphing them. What we're now going to do is flip that on its head and take graphs and write equations for them. There we go. So let's just jump right into it. Part A of example 1 wants me to write an equation in slope-intercept form given all of this hoopla information. Well, what can I take out of this depiction and convert to actual useful knowledge? And along the same lines, what is useful knowledge when I'm trying to write an equation in slope-intercept form? Really, there's two pieces of information I need for slope-intercept form. There's the slope, and there is the intercept. Strangely enough. So, is there any way that I can find the slope given this image? Absolutely. It pretty much is yelling the slope at you. Slope is rise over run, which in this case, it's a downgrade. So it's going down 3 and over 2. Negative 3 over 2. Slope, easy to find, not a big deal. Now, y-intercept. We know that the y-intercept happens when x equals 0. So is there a point on this graph that definitively tells you a place where x equals 0 and then there's a y-coordinate? Yes, there is. Y-intercept is 5. So, given that information, y equals mx plus b. So therefore, the equation for this must be y equals negative 3 over 2x plus 5. I hope that you thought that that was as quick and easy as I thought it was, because that's going to make this entire section go by like that. Let's do it again in part B. The difference between A and B here is that A had a negative slope, right? Negative 3 over 2. It looks like it's decreasing from left to right. B has a positive slope, increasing from left to right. So I should see the m value come out positive in this one. Let's take a look. Rise over run, I'm going up 5 and over 3, so 5 over 3. Again, just being thrown at us. And the y-intercept. Is there a place where x equals 0 and the coordinate point is definitively shown? Absolutely. Negative 3. Very cool. So y equals mx plus b. Y equals 5 over 3, a positive slope, which is good. X, and then plus b. B is negative 3, so minus 3. Fantastic. Example 1 done. You guys are going to be super good at that. I have no worries. Example 2. Which equation is shown in the graph? Okay, it looks like a horizontal line, and we haven't talked about horizontal lines in a while, but hopefully we can remember how we write a horizontal line. Well, all of these say y equals something, so that's a good start. Horizontal lines are equations that say y equals. Vertical lines say x equals. So at least we're on the right track with y. But let's see. This one right here, the fact that the 3 is attached to the x, that's telling me that there's a slope of negative 3. There's not a slope of negative 3. It's a horizontal line, which means there's a slope of 0. Alright, well, if there's a slope of 0, does that mean that the equation is y equals 0? No, it doesn't. Because if I think about y equals mx plus b, slope would go right here, which would mean that I wouldn't see any x's, because it would say 0 times x. So this wouldn't exist, but there'd still be a y-intercept. Alright, so y equals 0, not correct. What is my y-intercept, by the way? It's negative 1, 2, 3, negative 4. So what I should be seeing here is something that relates to a 4. Y equals negative 4 is a horizontal line at negative 4. Perfect. Now, lastly, our application. The graph shows the distance remaining to complete a tunnel. Write an equation that represents the distance, y, in feet, remaining after so many x months. So basically what this is saying is, when they started, they had 3,500 feet to dig. After a month, they only had 3,000 feet to dig. After 3 months, they had 2,000 feet to dig. After 5 months, they had 1,000 feet to dig. After 6, only 500 feet left, and so on. So we want to write an equation. Okay, so I mean, what we've been dealing with is y equals mx plus b. So we need some sort of y-intercept, and we need some sort of slope, some sort of rate at which they are digging. So basically every month, how much are they digging? Every time that a month of time passes, how much closer are they to their goal? And I could do this with formula. I could do this by looking, but by looking it's not always as accurate. So I think I might use the formula just to be absolutely certain. So I'm going to do y2 minus y1 over x2 minus x1. And what that's going to look like is 1,500 minus 3,500 over 4 minus 0. All right, 1,500 minus 3,500 is 2,000, negative. And 4 minus 0 is 4. So now how many times does 4 go into negative 2,000? Well, let's ignore the last two zeros. How many times does 4 go into 20? 5 times, right? So that's definitely a 5. Now let's add those two zeros back on. 500. It was a negative divided by a positive, which means negative 500. Awesome. So that's my slope, negative 500. So far I have y equals negative 500 x. Now I need a y-intercept. Looks like I'm actually given the y-intercept right in the beginning. After 0 months, they have 3,500 feet to dig. So that is my y-intercept, 3,500. I have my equation. Fantastic. Now what do I have to do in part B? How much time does it take to complete the tunnel? Now you might be thinking you have to compute something here. You don't. It's simply a matter of interpreting the intercepts. If I knew that the y-intercept gave me the amount of distance that I had to dig when I had just started, the x-intercept tells me how much time it takes before I have no more distance to go. Right? I was showing you before, after 3 months, they had 2,000 feet left to dig. After 4 months, they had 1,500 feet to dig. After 5 months, they had 1,000. 6 months, only 500 left. After 7, they're done. They made it to the end. So it takes 7 months. And that's simply by interpreting the x-intercept. Alrighty. Keep on working hard. Go to the assigned problems. I will see you in class. Make sure you write down your questions, and we'll talk about it later. Peace!